Okay, we're in section 22. I'm going to do the homework now. Some of this homework is going to require the use of a calculator. Certainly, if you do need help with the calculator, you can't use the calculator for whatever reason, including Sage, come by during office hours, and I'll be more than happy to help you learn how to use a calculator. All right, so let's start. Go to the whiteboard. All right, so section 22.3, homework. So let's talk about the first one. And the first thing I would do is over here is, certainly try to answer their question. Certainly that's my goal here, to answer their question. And to do that, I have to know what the question is. And that's going to require some reading. Let me just look at my notes, make sure I'm in the right spot. Yep, I am. So first thing I would probably write down is I'd write the function down. And what's the function? The function's f of x. The next thing I'd write down is I'd write down the derivative of that. So f prime is going to be 4x cubed. Now, certainly you want me to use a linear approximation to approximate delta f. And delta f, I'll write this down for you, it's written over here, is f of 3.02 minus f of 3. If I were to do that computation, not as an approximation, but the exact number, it would be 3.02 to the fourth power minus 3 to the fourth power. And I'm going to claim if you were to do that on a calculator, you would get this number over here. 136,356,01 over 625. Yeah, really lousy looking number, isn't it? 00. And this approximately, they didn't ask us to do this, by the way. This is approximately 2.18. What did they ask me to do? They asked me to use a linear approximation to approximate this. That's what they asked me to do. They didn't ask me to do the computation. They asked for a linear approximation. And what's that going to be? Well, that's going to be f prime at 3 times the delta x. Well, I haven't written that down yet. What's the delta x going to be? 3.02 minus 3, which is 0.02. All right, let's do that computation. And f prime at 3 is pretty simple. What's that going to be? It's going to be 4 times, let's see, that would be 3 cubed, right? And that would be 27. 4 times 27 is going to be 108. Let me make sure I did that right. 3 cubed is 27. 4 times 27 is 80 and 28. Yeah, 108. And then what's 0.02? I'm going to write it down as 2 100ths. And that's going to be 216 over 100. And now I can do the arithmetic without using a calculator, by the way, and that would be 2.16. All right. Now, by the way, I want to point out it's not a bad approximation. The actual number approximately is going to be 2.18. I mean, this is the actual computation over here, but they differ a little. All right. So 2.16. If you look at the answer key, you'll see that there. All right, let's go to number 2. And number 2, a very, very similar question, by the way, but now they really don't tell me what the delta f is. So I got to write that down. What's the delta f? Well, it's going to be f evaluated at, let's write this down. The a is 2. So 2 minus 1/2, because the delta x minus 1/2, minus f of 2. All right, I got that written down. And now what I want to do is, certainly I guess I could compute that. And what I mean by that, if I did do the computation, the exact computation, doing it, it's really not that bad to do. Again, if you need help with the arithmetic, please, I encourage you to come by and I'll be more than happy to do the arithmetic for you. But if you did this, without using a calculator, by the way, this one up here, I used a calculator. Use calculator. This one over, I don't need to use a calculator. I did it by hand and I got 49 over 102. And that's, if you thought about it, that might be a little more difficult, but this approximately, I used a calculator here. I did use a calculator, and this is approximately going to be 0.48. Approximately, by the way, I'm not saying exactly, approximately. So I don't think they asked me to do that. They asked me to do delta F approximately, right? So I have to get the derivative down. Let me go through that for you. And F of X, so write this on the side, is 7, and then 2 plus X squared to the minus 1. I'll be careful here. F prime, it's going to be minus 7, 2 plus X squared to the minus 2 times 2X. That's going to be minus 14X, 2 plus X squared. So we go back over here, and I want to point out the derivative is written down for you. And it can't hurt to check these things to make sure you're going along okay. Now, what do they do? Approximate. Let me put this over here. So what's delta F going to be? It's approximately equal to F prime evaluated at the A, which is 2, times the delta X, which is actually minus 1/2. All right, let's do that. I'm going to do that F prime at 2 now. That's going to be minus 28. And I'm about to put a 2 in there. I'm doing a derivative, by the way. That would be 36. And that's times minus 1/2. Oh boy, I got to do some arithmetic here, don't I? So let's take a look at it. I know it's a positive number. I'm going to start to divide by 4. And what would I get there? That would be 7/9. And I get a half still. So 7/18. I'm going to use a calculator. And if I do it on a calculator, 7/18 is approximately equal to, let me just get my eraser out. Erase this over here. It's approximately equal. I mean, again, I'm using a calculator. It's approximately equal to 0.389. Now, comparing it to the exact, value, that's pretty far off, isn't it? And maybe not. Far off is relative. And the reason for that, the delta X is much larger. It's minus 0.5. All right, so you'd expect that. So let's take a look at our K and see how we did. And we did okay. All right, I'm going to the next page. And next page is compute the error. And what's the error going to be? Let me write this down for you. The error, this is part B, is going to be the absolute difference between those two numbers. And I'm going to write them down for you. And the two numbers I'm seeing, the exact number is 49/102. And the approximate number was 7/18. Granted, I know it's tough. You can do the arithmetic though, but I want to point out it's okay to use a calculator. It's okay. All right. But this would turn out to be 14/153. All right. And then that's B. Let me see if I got that right. Yep. I see that right over there. The next thing is compute the error. And what's the error? I'm sorry, percent error. That's going to be C. Well, that's going to be the 14/153 over the actual exact number, which is 49/102. And this is a percent error. So I'm going to multiply by 100%. And again, I hate to say this, I'm going to use a calculator again. And I'm using a calculator to do that computation. And when you would get 400/21%. That's a crazy looking number, by the way. And this approximately, again, I'm using a calculator. This is approximately 19.048%. All right, let's go to the next page, see how we did. And I'm getting it right over here. All right, so that's not bad. We did okay with that. All right, so let's go to the next question. It says the cube root of 729 is 9. I'll write that down. So the cube root of 729 is 9. Okay, so it says, how much larger is, well, I got to write that down. How much larger is the cube root of this thing? So I'm going to say f of x is a cube root function. And that larger part is really going to be a delta f now. And what's a delta f equal to? Well, they're asking a question. How much larger is it? So it's going to be f of 729.6 minus f of, that's a delta, how much larger? 729. Now, granted, I don't want to do the computation. I guess you could though. And I'm going to see if I've done the computation. I'm going to look at my notes. I want to see if I've done the computation on a calculator. I don't know if I've done that. Yeah, I did. And I'll write this over here. So on a calculator, I'll put this over here on a calculator. This is a calculator. I actually did the computation, and what I got was this 0.002468. Yep, I used the calculator. They didn't ask me to do that though. They're asking me to approximate it. And so I'm going to go through it, and to do that, what I need to do is I need to find f prime. And what's that going to be? Well, f of x is x to the, oops, sorry about that. I forgot the equal sign there, didn't I? Equals x to the 1/3. So what's that going to be? It's going to be 1 over 3. That's going to be the cube root of x, whole thing squared. All right. Take your time to get the derivative, certainly. So I'm going to keep moving forward, and I'm going to try to get that approximation. And what's the delta f going to be? Well, let's write this down. It's going to be f prime at 729. Well, I didn't write the delta x down yet. I'll put that down for you. And the delta x is going to be the difference between 79.6 and 729, which is 0.6. Let's write that down. So you get 1 over 3 times the cube root of 729, which is 9 squared, right? Just plug it into derivative. Whoops, I forgot something here. I get my eraser out. This is times the delta x, and the delta x is 6/10. Sorry about that. So f prime at 729 is going to be 1, 3. The cube root of 729 is 9 squared times 6/10. All right, we have a key to look at. I make mistakes with arithmetic, and I'm not denying it. And what would that give you? Well, let's see. 3 goes into 6 twice. 2 goes into 10 is 5 times. So it's going to be 5 times 81, which is 1 over 405. All right. I actually did that computation on my calculator too. I got to look for it. I get scrap paper over here. Yeah, this one turns out to be approximately 0.00246. And I used a calculator. I'm actually like, no, I use a calculator. So let's see if we did that. Let's see if we got that number, and I'm seeing it right over here. All right, so I used a linear approximation to find it out. This is substantially different than the other one. No, because you have to start to realize, relatively speaking, 0.6 when you're at 729 is not a big change. It's not a big change, all right? And I'm using relative terms over there. That's number 3. Number 3 is done. Again, the answers are all there with the work, and we're just talking through the work. All right. This one says, oh, this is different notation. This is delta y. So delta y is going to be, well, it's going to be y evaluated at, let me write this down for you, pi over 60 plus, well, that's going to be 2 100ths minus y evaluated at pi over 60. All right, I'm gonna look at my notes, see if I made that computation for you. I don't know if I did. No, I didn't do it. I don't want to do it either. It's just too much work. So what I want to do is I want to approximate this thing. So delta y is going to be the f prime. It's not f prime. It's going to be y prime evaluated somewhere times the delta x in the problem. All right. So let's see if we can get the derivative first. And what's that going to be? Well, y prime is going to be minus 10 sine of 10x. I think I did okay there. So it's going to be y prime evaluated at pi over 60 times, this is 60, sorry about that, times a delta x, which is 2 100ths. Let's see if we can do this. All right. I'm sorry. I'm getting fudgy with the notation. It's approximately that. So what's y prime pi over 60? Let's write this down. I don't need that symbol. I'm going to erase that now. This will be equal to, well, y prime pi over 60 is minus 10. And that's going to be sine of pi over 6, right? Times 2 100ths. Write that down. Well, I got some work to do. This is minus 10 and pi over 6, right? Let me go through that with you. Well, that's a 30-degree triangle, right? So something like this over here. Well, that's just 1/2, right? And again, I have an answer key. I'll look at it later. I'm going to simplify that. That's minus 1/10, right? Which is minus 0.1. So I'm going to say the delta y is approximately equal to minus 0.1. We got that right over here. All right, we did okay. Let's go to 5. Now 5 is really probably the simplest question in the set. They want to find a linearization. And also linearization is really the equation of a tangent line. So let's write this down. So I'm going to put the linearization down for this. And yeah, I know what f of x is. So f of x is 7x to the 5th. The point we're looking at is 1, 7. And we're going to put an equation of a tangent line down now. Before I do that, though, I got to get the slope. So f prime is going to be 35, and 7 times 35, x4. And f prime at 1 is 35. So I'm going to write the equation of the tangent line down. So it's going to be y minus 7 equals 35, which is slope, x minus 1. I got to work on this. And that's going to be, let's see, y equals 35x, and that's going to be minus 28, right? Now we call y a linearization. So I'm going to write down the notation that your book is using. They say L of x, which is equal to y, is 35x minus 28. I'm going to put a circle on that, and I'll put this over here. We got that too. All right, let's go to 6. 6 wants me to estimate the square root of 9.2. So let's write this down. So, oh boy, I guess we're going to use linearization, right? So that's what they say. So f of x equals the square root of x. And then what do I got to do? I got to do f prime. That's 1 over 2 root x. And what's a nice number near 9.2? I'm going to say I'm going to use 9. So I want the point at 9. So x is going to be 9. And what would the y be? The y would be 3, because square root of 9 is 3. And what's the slope? What's going to be f prime evaluated at 3? And that's pretty simple. It's going to be 1 over, and what do you get there? 2 times 3, which is 6. So the equation of the tangent line, they said use linearization, which is tangent line, y minus 3 equals 1/6 x minus 9. I'm going to write the linearization function down, which is going to be y equals 1/6 of an x minus 9/6 plus 3. Y equals 1/6 of an x minus 2/3. That's what 9/6 reduces to. And this would be 9 over 3. Whoops, I made a mistake. I just noticed it. Let me go backwards. I'm just daydreaming. So that's going to be minus 3/2. Sorry about that. Plus, I'm going to get over there. That would be 6/2, right? So y equals 1/6 of an x plus 3/2. Right, this is the linearization, provided I didn't make a mistake. All right, let's take a look and see if they've got that. And I'm seeing that right over here. Now they want to use a linearization to approximate the square root of 9.2. So what I do? L of 9.2. Let me write that down for you. And that's going to be 1/6 times 9.2 plus 3/2. Oh, I just went a little too far there, didn't I? I guess we have to do the arithmetic because they did it, right? I got to go through it. I'm not going to use a calculator either. So this is 1/6. This would be 92 tenths plus 3 halves. Yeah, it's crazy. I realize this. I can't do arithmetic. You got to learn. So let's take a look at that. I'm going to divide through by 2, 46 over, if I divide 2, that'd be 30, right? Plus 3 halves. Going to keep going. I'm going to divide by 2 again. That's 23/15 plus 3 over 2. Comes out, it'd be 30, right? Let's see, 46 and 45, which would turn out to be what? Let's see, 91/30. All right, I'm going to say the square root of 9.2 is approximately equal to 91/30. All right. Now, if you want to reduce that, I'm sorry, if you want to divide through by that, you can. Let's just look over here, see what they got. And they got 91/30. However, they did use a calculator. And then 91/30, they used the calculator. You know what? Let's not use a calculator. Let's just do it. 30 into 91. That goes 3. You get 90. And when you get 1 0, got to add a 0 there. 100. I think you get the idea. 3. That'd be 90. 10. You get the idea. All right, let's go back over here. And what are you getting? Well, you're getting something. It just keeps repeating over and over again. 3.033. All right, not so bad. All right, I realize this for some students is a confusing section. You're not alone in that. All right, you're also not alone in the usefulness of it. With the advent of calculators, we really not using these things to approximate, but it gives you some insight into derivatives though. So thank you for paying attention.